Okay, in this example, we are going to be graphing a sine function for one cycle. The sine function we have is this one over here, and you can notice that there are a few transformations going on. We have a vertical stretch, we have a horizontal shift or a phase shift to the right 30 units or 30 degrees, and we have a vertical shift up 1 unit. So before we do this, I just want to graph an original sine function for one cycle so we can kind of see what happens to it. So let me zoom in over here. If you recall, the sine function starts at 0, at 90 goes to 1, at 180 goes to 0, at 270 goes to -1, and at 360 goes back to 0. I'm going to connect those with a nice smooth line. It goes up like this, down like this, and comes back to 360 over here. Okay, let's zoom out, go back to our original. I'm going to be using a method that I've used before when graphing any kind of function. I guess you call it a mapping notation, namely that if I have a coordinate x comma y, each point will be mapped to 1 over b x, okay, minus the h value, comma, ay plus the k value. Now in this case, there is no b value. There's nothing changing the value of theta in front multiplied by theta in front. So I'm going to simplify this, take that out, and this will be our the equation that we're going to, or the mapping notation we're going to be using. Let's put in the details from this question here. So we have, in this case, let me zoom in actually a little bit. We have x comma y is going to be mapped to x minus -30, which is just going to be plus 30. So I'll just save myself the step and do plus 30, comma, -2y plus 1, because we are multiplying by -2 and then adding 1. So this will be the mapping notation I'm using for this question. I'm going to take this and maybe move it over. You know what, I'll just keep it there. And I want to see what are the values of x, y that I'll be using. Well, obvious one is going to be over here, 0, 0. I'm going to use 90 and 1, 180 and 0, 270 and -1, and 360 and 0. So what happens to the point 0, 0? Well, according to our notation, we get 0 plus 30 and -2 times 0 plus 1. Or that's just 30, -1. So let me see if I can maybe, actually, you know what, I will move all this. I'm going to need some space. I'm going to put this over here, and this is my final point. So this is equal to that. Then I'm going to get 90, 1, and that's going to go to, we have 90 plus 30, and -2 times 1 plus 1. That will bring us to, oh, sorry, the previous one was +1. That will bring us to 120, comma, that will be -1. Okay. Next, we have 180, comma, 0. That's going to bring us to 180 plus 30, and -2 times 0 plus 1. That's going to be 210, comma, what do we have here? +1 again. Then we have 270, comma, -1. That's going to map to 270, oops, let me just change that, 270 plus 30, comma, -2 times -1 plus 1, and that will be 300, comma, 3. And lastly, we have 360, comma, 0. That'll map us to 360 plus 30, comma, -2 times 0 plus 1. I don't need that comma there. And that'll bring us to 390, comma, +1. Okay. A lot of calculation going on here. I'm just going to take all this. Actually, before I do that, let me just put the points in. And I'm going to just take these blue highlights out. And I'm going to map my new graph, or sketch my new graph using, let's use green here. So what are my points? What are the points I'm going to be using? So I have 30 and 1, which is going to be over here. I'm going to have to move this out of the way just a smudge for now. Just move this over a little bit. So again, I'm using these points here. I'm using this one, this one, this one, this one, and this one. So the first point is 30 and 1, which is going to be here. The second point is 120 and -1, so that's going to be over here. Then I have 210 and 1, 210 and 1, and then I have 303, which is going to take me off the grid. So 270, 303, well, it's going to be kind of somewhere up here. You won't be able to see it actually. And 390 and 1, so 390 is going to be here, and there we are. Okay. Let me connect these dots together. I'm going to be coming down, turning up, going off the page possibly, and coming back down. And that will be my graph. So, does this make sense? Let's take a look at the original. We have a reflection, which means the graph is reflected. Definitely that's the case. I mean, if you look here, the original graph is, reflected in the x-axis. We have a stretch by 2, and that certainly is the case, because if you look at the distance between the middle here and I guess the lowest point, I mean, that's an amplitude of 2. So that's good. What else do we have? We have a shift of 30 degrees to the right. Is that happening? Do we have this 30 right? And yes, we do. Remember, we're starting at 0 and we're shifting everything over, and that first point is, or that first block is 30 degrees. So it is moving to the right. And finally, everything is shifted up 1 unit. Is that happening? That is happening indeed, because you'll notice that the sinusoidal axis, which is in the middle here, has been moved up 1 unit from where it was here. And there you have your vertical shift of 1 unit up. So that's our graph. I use this method. There are other methods that you can use to graph. You can do each transformation one at a time and see the effect it has on the graph. There's another method where you actually just draw a sketch. But anyways, I will maybe try different methods in other examples. Okay, but you use the one that suits you best.